Two.
Family Math number 109.
Family Math number 109. Okay, so I had a question. A friend of mine from high school sent me yesterday. Remember the prime video we talked about, and the sum of the inverse primes adds up to infinity?
Mm-hmm.
And he asked me, how do you do that? And it turns out it's actually pretty difficult. But I wanted to show one infinite series that also adds up to infinity. That we can. So it's the sum of the inverse integers. 1 plus a half plus a third plus a fourth plus a fifth. And by coincidence, I saw a really cool proof of this today on Twitter. And by double coincidence, you and I just started talking about fractions today, right?
Yeah.
So this is pretty neat. So you even know what a fourth means, right?
Yeah.
Okay, so the only thing we have to do to show that this sum all the way out, if you wrote them out to infinity.
Yeah.
Actually, do you want to turn the camera off and write them all out to infinity for me?
I don't think so.
No, you have to go to bed, don't you?
Yeah.
Okay, well, never mind then. Okay, one thing we have to figure out before we do anything, and this is really the whole point of the first proof, is 1/3, and just zip on this, is 1/3 bigger than 1/4? Or is 1/3 less than 1/4? What do you think is bigger, a third or a fourth?
I think a third's bigger.
Okay, why is that?
Because 3 thirds equals 1 and 4 fourths equals 1.
Okay, very good. 1/3 is bigger than a fourth. What about a fifth and a sixth? Which one's bigger?
A fifth.
A fifth. So as you go down the list here, these numbers get smaller, right?
Yeah.
Yep. Okay, so if I changed some numbers and made them smaller, I'd make the sum smaller, right?
Yeah.
And if I made some numbers smaller and showed you that the sum of the smaller numbers was infinity, it would mean the sum of the bigger numbers was infinity too, right?
Yeah.
Okay, so I'm going to make some numbers smaller.
Alright.
Okay? I'm going to make a new sum, and I'm going to write it in the middle here. 1 plus a half plus a fourth plus a fourth. That's smaller, right? Because a fourth is smaller than a third.
Yeah. Yes.
Plus an eighth plus an eighth plus an eighth plus an eighth. Now, this is smaller, right? Because an eighth is smaller than a fifth.
Yep.
An eighth is smaller than a sixth.
Yep.
An eighth is smaller than a seventh.
Yep.
And an eighth is smaller than an eighth, right? And now I'm going to write an 16th here, plus a 16th, and I'm going to write that all the way to over here. And what do you think I'm going to do next for the numbers that go up to 32?
32nd.
32nd. Now, let's see what my green sums add up to. I get 1 plus a half.
And then,
right?
but 2 fourths is a
And
half.
then I get plus 2 fourths. Oh, actually, you know what? Let me do it down here so I don't make it too confusing. I get 1 plus a half.
Yeah.
Plus 2 fourths.
Which is a half.
Which is a half. Plus 4 eighths.
Which is a half.
And then this is going to be 8/16.
Plus 8 sixteenths.
Which is a half.
And then I keep going on forever, and I get 1 plus a half plus a half plus a half plus a half plus all the way out forever.
That's infinity.
That's infinity. But these numbers are smaller than my other sum, right?
Yeah, but
So that means this sum is also
That means the
infinity.
purple sum is also infinity. Does that make sense?
yeah.
Yeah.
Okay. Pretty neat, right?
Yeah.
Yes.
Okay, so this one's actually not too hard to show that it goes to infinity, because I can show a smaller sum goes to infinity. But here's the really cool proof I saw today that I'd never seen before. Okay?
Okay.
So I'm going to call our sum S, and I'm once again going to make a new sum. And it's going to be a half plus a half plus a fourth plus a fourth plus a sixth plus a sixth plus an eighth plus an eighth plus a tenth plus a tenth plus a 12th plus a 12th, and so on. Okay? Is my green sum bigger than my purple sum, or is it smaller than my purple sum?
I think it's smaller.
Why?
Because a fourth is smaller than a third.
Okay, I left the even reciprocals the same, a half, a fourth, a sixth.
Yeah.
And I changed the odd ones to one smaller, right?
Yeah,
Well,
yes.
one reciprocal smaller.
Yeah, but doesn't-
one became a half, a third became a fourth, a fifth became a sixth. So I made them all smaller, right?
Yeah, but doesn't these two sums equal each other?
Hold on a second. The green sum's definitely smaller, right?
Yes.
Okay, so if I call the green sum S, purple S, or I'll call it S star, we know that purple S is definitely bigger than the green S, right, or S star.
Yeah.
It's definitely bigger. Now, you said they're the same. Why is that?
Well, because you can group them. 2 halves is 1, 2 fourths is a half, 2 sixths is a third, 2 eighths is a fourth, 2 tenths is a fifth, and so on.
Ah.
Cool.
So it's bigger.
But
It's definitely bigger, right?
Yes.
Because I made some numbers smaller.
Yeah.
But you just showed that you can group this. A half plus a half gives me that 1. A fourth plus a fourth gives me that half. A sixth plus a sixth gives me that third. An eighth plus an eighth gives me that fourth.
Yep. And a tenth.
Oh shoot, I wish I could remember who put this on Twitter today. I totally forgot. I'll put it on the blog though.
Okay.
Okay. So not the purple sum's bigger, but it's equal. So how can a number be bigger than something but also equal to it?
But then it's infinity.
It's infinity.
That's cool.
Yeah. How neat is that?
Yeah, it's
Alright.
really neat.
Good job. Hey, good job noticing that the green sum was equal to the purple sum. Did you just see that?
Yeah.
That's really awesome. It actually took me a while to see that when you put it on Twitter. Pretty fun, right?
Yeah.
Yeah.
All right. Good job, guys. Good job.